Alright, we're back with geometry 6.2, properties of parallelograms. Alright, on this first drawing, let's label this as so. We're going to put point A. Let me change this to a pen. Here we go. We will write point A here. We have point B on the left. We have point C. And we have point D. Alright, so we've labeled this parallelogram ABCD. They want us to draw a diagonal from B to D. We can do that. Let's try and make this as straight as possible. And there is diagonal B to D. Alright, next, we're going to try and prove that triangle ABD, this triangle is congruent and equal to triangle CDB. And so they want us, or they're asking us to prove that, and we're either going to use side, 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 side angle, side, etc. Well, a few things that we can do here. One, we're given that this shape is a parallelogram. So that helps us out, because what I can do now is I can say, okay, these opposite sides are congruent and parallel, right? So these two sides are congruent and parallel. These two sides are congruent and parallel as well. Okay, well, now that's pretty much, sorry about that. That's pretty much all that I need to do, because now I can say that I have side, 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 and by reflexive property, I can now say that these two triangles are each congruent by side, side, side. Okay, and that is the easiest way that we can see it. However, there's more ways. So let's change this color. Since we know that these lines are parallel, cut by one transversal, alternate interior angles are the same. So let's put a mark here and a mark here. We also know that these lines are parallel as well. So we have two parallel lines cut by the same transversal. These two lines are parallel, or these two angles are parallel, or these two angles are congruent by alternate interior angles, and these two lines are parallel. Okay, so now what I've created is I have side angle side, and I have side angle side, so I can put SAS. Alright, now I'm still not finished, because since we were told that this shape is a parallelogram, opposite angles are congruent. So let's put 3 marks on angle C, 3 marks on angle A. Now what I have is angle side angle and angle side angle to prove that the same triangle is congruent. But we're still not done. Next, if I look at what else I'm given, I have angle, angle, side, and angle, angle, side. So we could also use angle, angle, side. Okay, so that's just for your own knowledge. You wouldn't have to do that on a quiz. You wouldn't have to prove this all 4 ways. One way is fine. Alright, up the top we have opposite angles are congruent. I guess let's spell it out. And we know that consecutive angles are supplementary. Now, with consecutive angles, let's keep in mind that these are same side interior angles. And this goes all the way back to Unit 2, where if we have two lines that are parallel cut by one transversal, angle 1 and angle 2, these two angles have to add up to 180 degrees. And so if we were to close this shape up, then what you can see is that angle 1 and angle 2 are consecutive angles. Alright, and if we put angle 3 and angle 4, I have angle 1 and angle 2 would be considered the two angles that are consecutive. I have angle 2 and angle 4 would be considered consecutive angles. Angle 3 and angle 4 would be considered consecutive angles. And the only one I don't have listed would be angle 1 and angle 3. Those are also considered consecutive angles. And they're also considered same side interior angles depending on which two lines that you look at and which transversal. Okay, and so these angles will add up to 180 degrees. They're supplementary. Alright, moving back to our triangle. And let's change this to CPCTC, because that's really what this is saying, that by CPCTC, I can now say that segment AB is congruent and equal to CD. Okay, and also by CPCTC, let's change that here. I could say that angle A was congruent equal to angle C. Now, we already showed that because we were told that this shape was in fact a parallelogram. Okay, but since we've shown or proved that these two triangles were each congruent by side, 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 then their corresponding angles and sides and parts are also going to be each congruent. All right, then theorem 6.1 is going to say that in a parallelogram, opposite angles are congruent. And theorem 6.2, in a parallelogram, opposite sides are congruent. All right, moving down below, here's a problem. Now, we're told that the shape is a parallelogram, therefore opposite angles are congruent. Set them equal to each other. X plus 15 equals 135 minus x. Negative 2x, actually positive 2x equals 120. X equals 60. That gives me a 75-degree angle here and a 75-degree angle here. Now, we have to stop for 1 second because it's asking for the measure of angle A. Well, angle A and angle B are consecutive angles. Angle A and angle D are consecutive angles. They add up to 180 degrees. This has to be 105 degrees. That's angle A. Next, opposite sides are congruent. This is an easy one. A has to be 5 plus 4, which is 9. B is going to be 7. All right, next we have solve for A and B. We're going to say that these two sides are congruent. So 2A minus B is equal to 5. And these two sides are congruent. A plus 3B is equal to 6. We're going to use elimination. We're going to multiply the top by 3. And that gives me 6A minus 3B equals 15. Here is A plus 3B is equal to 6. We get 7A equals 21. A is equal to 3. And we plug 3 back in. 3 plus 3B is equal to 6. 3B is equal to 3. B is equal to 1. So we have A is 3 and B is 1. All right, next problem at the bottom. We're going to draw both diagonals, so let's do that now. Here's one diagonal. Here's our second diagonal. And they intersect at point E. Now, I'm not going to put point E in there because we're going to make a lot of markings on here. And this is at the end of this problem, it's going to be very hard to see exactly what we've done. So just know that going into it. This is a very small shape, and we're going to make many markings. Okay, so I'm going to leave E outside, but E is really this point here. But if I put point E inside, I won't be able to mark this up the way that I want. All right, ask how many triangles did you create? Well, I see 1, 2, 3, 4 right off the bat, but then I see 5, 6, and then 7 and 8. So there's actually going to be 8 triangles, and that's hard to see, but they are there. All right, draw a squiggly line. We're going to do this in steps. So we're going to do this first. We're going to do this problem second. All right, we have triangle DEC is congruent. Now remember, DEC is going to be this triangle on the right, and we're going to say that it's going to be congruent to this triangle on the left, which would be triangle BEA. But we need proof, okay? So I'm going to draw an arrow up here because we need proof. So one, we see that vertical angles are congruent. And we also have one mark here and one mark here. Okay, so right now we have side angle and side angle. Well, keep in mind we're given that the shape is a parallelogram, so we have to use that to our advantage. So the way we use that to our advantage is that these arrows, these are parallel lines cut by one transversal. That means alternate interior angles are each congruent. So if we look at this line that's parallel and cut by this transversal, that would be this angle down here. And we look at this line that's going to be cut by this transversal, that will be this angle here. Okay, and so since these two angles are each congruent, we have angle, angle, side, angle, angle, side. Okay, so this is true by AAS. Okay, then by CPCTC, I can say that DE, let's put 2 marks here, is congruent. Now again, we're proving that these two triangles are the same. So DE would not be AE, DE would be BE. Those two sides are corresponding sides, or the same sides of each triangle. So DE is congruent equal to BE by CPCTC. Alright, we're going to do the same for triangle AED. And so that would be this triangle in here. We're going to put 2 marks and 2 marks. These two angles are the same. Also highlight these 2 marks and these 2 marks. So we have angle side and angle side. So we're trying to prove that triangle AED is congruent to triangle BEC. And again, we need proof. So just like last problem, we had side angle and then side angle. We have the same thing here. And just like last problem, we're going to use alternate interior angles to prove that these two triangles are each congruent. So let's look at this line that's parallel to this line, cut by the same transversal, and put 3 marks here and 3 marks here. So now we have angle, angle, side, and angle, angle, side. We have to ignore these marks in red for now. So this is angle, angle, side. And then by CPCTC, I can say that segment AE, let's put 3 marks on AE, is going to be congruent to CE. And that leads us into our next theorem, which is theorem 6.3. In a parallelogram, diagonals bisect each other. And that's exactly what we have shown. So we're going to draw this segment. Now, we have to understand this. This is kind of a new term. And when you think of the term bisect, okay, this means to cut in half. So let's reread that. It says that in a parallelogram, diagonals will cut each other in half. Okay, so that's kind of a weird thing. But when I draw this diagonal, let's say that this was A, B, C, and D. And then, so here is segment AC, which is one diagonal. And our second diagonal is going to be segment BD. Okay, well, one thing that this is not saying is these two segments are not equal. That's not what we're saying. Okay, in fact, segment AC is going to be greater than BD. Why is that? Well, one, it just looks longer. I mean, think about how this shape is slanted in these corners. So this segment has to be longer than this segment, and therefore AC is greater than BD. But what we're saying here is that this point at the middle, let's call this point M. We're saying that this point M is the midpoint between both segments, or between both diagonals. So what you can say is that AM, and again, M is this point here, AM is congruent and equal to CM because it's on the same segment, same diagonal. And then what we can also say is that BM is congruent and equal to DM. All right, and we can put 2 marks here. But what we're not saying is that AC, or that these two diagonals are each congruent. We're not saying that. We're just saying that diagonals bisect each other, which means that they cut each other in half. Alright, so we're going to apply the rule that we just learned about diagonals bisect each other. So again, this was theorem 6.3. So since these diagonals are going to cut each other in half, we know that 8 plus 4 is equal to 8. And we know that 2b minus 1, we'll put 2 marks and 2 marks here, is equal to 9. And again, you can just tell that this diagonal is longer than these shorter diagonals. So we're not saying that these diagonals are congruent. We're just saying that this point is the midpoint of both diagonals. So A is equal to 4, and then B would be equal to 5. So A is 4 and B is 5. And that would make sense because we get 8 here and we would get 9 and 9 there. Alright, next we have A is equal to B plus 2. And we have B plus 10 is equal to 2A minus 8. I would use substitution here. It's set up for that. We're going to circle b plus 2, substitute into this a down below. So b plus 10 is going to equal 2 times parentheses b plus 2 minus 8. We get b plus 10 equals 2b plus 4 minus 8. Negative b is equal to negative 14. b equals 14. And so if b is 14, then we get 16 for a. So this would be 16 and 16. And then this would give us 24 and 24. Okay, and so again, that would make sense because this diagonal is longer. That's why we have 24 and 24, which would be 48 and 32. All right, the next drawing is basically just a pattern. And what we're saying here is that if these three lengths are each congruent, so if these three segments are each congruent and we have all these lines are parallel, then what it means is that these segments, these lengths are congruent as well. So if I just made up a length or a distance and I said, hey, from here to here is 4, right? Then that means all of these would be 4. And then we're not saying that these are 4 as well. These could be anything. They appear to be a little bit longer. So let's put 5, 5, and 5 all the way down. And so this is just a pattern, and we can see that because these arrows means that these lines are parallel, and since these are the same, these three will also be the same. Okay, and we can put our marks here, 2 marks, 2 marks, and 2 marks. All right, if AB is 4, then BC is also going to be 4, and CD is also going to be 4. So BC would be 4, and that means from A to D, if we added them up, 4 plus 4 plus 4, we would get 12. All right, next for DC, we have DC and AC. Now, when we look at this, we see that from DC is actually, we need 2 of DCs to equal 1 of AC, right? From D to C and then from A to C, we need 2 of these to equal 1 of AC. So we're going to take 2 and then multiply that by 2x minus 1 because that's our length of DC, and it's going to equal 1 times 8x minus 6. So solving, we get 4x minus 2 equals 8x minus 6. Negative 2x equals negative 4. Sorry, negative 4x equals negative 4x is equal to 1. All right, and then over to the other side, if we look at EF and we say that EF is 5, that means all of these will be 5. But what else do we know? We know that FG, well, we know that it's going to be 5, but we're told that it's x plus y. So we have x plus y is equal to 5. And then GH is also going to be 5, but we're told that GH is 3y minus 2x. Okay, but that's also going to be equal to 5. One thing that I would do here is I would rewrite this out and make sure your x's and y's line up. So let's rewrite this as x plus y is equal to 5, and then negative 2x plus 3y is equal to 5. From here, we can multiply the top. Let's choose negative 2. Sorry, let's choose positive 2. We get 2x plus 2y is equal to 10. And then underneath, negative 2x plus 3y is equal to 5. We're going to add these up. The x's cross out. That gives me 5y equals 15. Y is equal to 3. We plug 3 back in, and x plus 3 is equal to 5, which means x is equal to 2. So today in a parallelogram, we learned that opposite sides are each congruent. We learned that diagonals will bisect each other. We also know that opposite sides, comma, opposite angles are each congruent, and that consecutive sides are supplementary. And remember, that's going to add, or not consecutive sides, excuse me. Consecutive angles are supplementary. They add up to 180 degrees. All right, next, do you think that some of these none of these or all these will be true for a rectangle. Well, again, if we were starting with mammal and we went down to certain types of animals, they're all going to have certain characteristics of mammals, like having hair. Okay, so since we're starting at a parallelogram and we're working our way down towards a rectangle, all of this genetic material that's in this parallelogram will get passed down to all shapes. So this will get passed down to a rectangle. So this is going to be always true. Okay, same thing for a rhombus. Everything that's inside this parallelogram that's true will also be true for a rhombus. So we're going to put all of this will be true. And it's also true that to our square, again, since we're starting at our parallelogram and it's going down, the square will contain everything that a parallelogram contains. This will always be true as well. Last part, the algebra review. Let's factor x minus 5 squared. This would be x plus 7 squared. Remember, this could be x minus 5 times x minus 5. This could be x plus 7 times x plus 7. We have to think outside the box here. 2x plus y times 2x plus y. When we FOIL that, we get 4x squared plus 2xy plus 2xy plus y squared, and that gives us what we have here. So this is correct. 2x plus y times 2x plus y, or 2x plus y, and that would be squared. Thanks for joining us. See you next time.